All right, so the one we're looking at is this, right? This integral. You can talk. You'll just, be famous on the internet. All right. Oh, not theta yet. Dx. All right. So we're going to make this substitution, right? X equals 3 sine theta. Everybody okay with that, right? So then you want to change dx as well, right? So dx is going to become 3, cosine theta, right? D theta, right? Okay, so now when I change the integral, you should end up with this. When you square that 3 in the substitution, you're going to get 9 sine squared theta. And the differential becomes this. So this right here is from the differential, right? And remember, in this case, you multiply by the differential, unlike W substitution. So now I want to focus on the bottom, right? So the bottom here, the whole point of this substitution is to simplify the square root, okay? So if you factor out the 9, that lets you see that you want to use a trig identity, right? 1 minus sine squared, we know is cosine squared. And this is technically absolute value, but because we're only thinking about theta being in those arcsine regions, it's okay just to write 9 cosine theta, okay? Oh, sorry, 3 cosine theta, right? All right, so that's going to be our denominator, right? But that's also our numerator. So now it becomes 3 cosine theta over 3 cosine theta. Okay, so now at this point we can just simplify to, well, d theta. And so that's going to just become theta plus c, right? But just like W substitution, if there's not limits, we need to go back, right? So we need to go back to x, okay? So let's think about our substitution. That was x equals 3 sine theta. So I need to solve it for theta, right? So I'm going to divide by 3. Then I'm going to take arcsine of both sides, and that equals theta. Okay, because we're only using those values anyway, so that's okay. I just wrote a phi instead of a theta, but you know what I meant. All right, so now the final answer then is going to be arcsine x over 3 plus c. And while I'm still recording, let me just mention, when you look at that original integral, that shouldn't be too terribly surprising, because what's the derivative of arcsine of x anyway? It's this with a 1, right? If you had a 1 instead of a 9. So it shouldn't be too surprising that it ended up looking like arcsine.